Hi folks, this is part 2 of the Sainsmart LED watch kit, and this part is basically going to consist of me actually building it and showing you it working. You recall from the last video I had to trace out the board to find out which way the battery goes round, and then it brought me onto the LED display and you know, trying to work out what the polarity of that was. I thought various ways of doing it, but the easiest way was to Google it, and you can actually get from Sainsmart the construction guide. So I won't show you it all. Well, I will. It's just it's very basic. It just shows you how to solder and stuff. And what it says on here is 7-segment display. As you insert this part, make sure the number 3642BH is facing you. Your display won't work upside down. After soldering all legs, cut off any excess. Right, I don't have that number, but there is an ASR. It says ASR on there, so we'll go with that pointing towards us and see if it works. And yeah, it does show you that the negative does go to the switch as I showed you in the previous video. Yeah, so just one other thing. This part, I'm not sure. It shows it as one complete piece in the instructions. But I think it's just been a little bit close cut with a laser, but it's just cosmetic anyway, so once it's on it should look okay. So we'll just go ahead and build the thing. As with all electronic kits, the best way to do it is to start with the lowest profile components first, and that just makes assembly a little bit easier. So first of all, we'll just put our resistor in, and we'll splay the legs out slightly just to hold it in place while we solder it. And if you're new to soldering, I'll just talk you through the process. So we shouldn't need a lot of solder for this kit, and if I zoom in slightly, we should hopefully be able to show you. So the first thing to do is tin your iron. So have it set at a reasonable temperature. This is set at 300 just now, which is, you know, doable for this type of kit. So tin your iron first, just get a little bit of solder on there, and what you've got to do is heat up the actual PCB, so the track itself and the leg of the component. So heat them both up together, get them up to temperature, apply the solder, and then pull your iron away. It's important to leave the iron on there after taking the solder away, and that just allows the solder to flow and create a nice joint. Okay. Right, so the nice thing about this kit is the PCB is through hole plated, which means the solder will actually flow into the hole and you know, secure the component in place. So you can see there's not a lot of solder on there, but it's a nice shiny smooth joint. And if you look on the other side, the solder has come through as well and has totally secured that component in place. So that's pretty much ideal. You could argue maybe slightly more solder on there, but you know, this is low voltage, you know, low current, and you know, by that fact it's going to be low heat, so you know, that's perfectly acceptable for this circuit board. Next lowest profile component we've got is our crystal. So best thing to do with smaller components, we're going to have to form the leads on this one, just so that it fits nice to the board, because this actually gets put on a board horizontally. So if you look at the PCB, of course it might be tempting just to solder it in flat like that, but we're going to form the leads so that it lies flat on the board. So we're going to do that just about halfway along the leads, and just gently bend them to a 90-degree angle. I really need to stop throwing it around though. And then just pop that into the board like so. And we'll just use the weight of the board to hold the component in place. Always clean your iron as well. I'm just using one of these sort of copper sort of Brillo pad things. Tin your iron. There we go. One side. And on these components, if you're only once you've soldered one leg, just adjust the component and then tack up the other side. Okay. Yeah, that's good. And just as we're going along, just trim the leads off to make it a bit smoother. Perfect. Right. Okay. So I think the next logical thing to put in would be the IC holder. That's because the ceramic capacitors are probably just slightly higher than that once once you've taken into consider the little bit of leads you'll need to, because you have to bend the leads out, and it will make it sit slightly proud from the board. So this is the next sort of smallest component, and what you need to do here, if you look at the PCB, there's a notch on the end indicating that pin 1, the dot, and there's also a notch on the end of the socket. So we want to line those up. Yep, and again we'll just use the weight of the board. Just popped out. Just use the weight of the board to hold that in place. I'll probably just use that under just to prop it up slightly. Now my top tip when soldering an IC, if you solder it into the board itself, or solder it into or soldering a socket in, I like to tack up one side like so, and then go to the opposite corner. And once I've done that, I take it out, I check it to make it flush, make sure it's flush to the board like that is on both sides. And then once that's done, I will then solder the rest of the board up, sorry, rest of the socket up. Now what I do is I start from I start at one corner, and then I'll go to the opposite corner, and I go to the other corner, then the other corner, and all I do is I just keep cycling through that until it's complete. Now the reason I do that is because these sockets, they're made of plastic. The cheaper ones are made of plastic. One more expensive one's a sort of a glass reinforced plastic, but on these really cheap ones, they are literally just plastic. And if you're soldering all in one area for a length of time, you run the risk of melting the socket and deforming it, and that's obviously not going to be good. So by doing this way, you're spreading the heat out. Nearly there. And don't be, let's say, because these are through hole plated, don't be surprised if some look a bit more prouder, you know, a little bit more soldering one than another. It's just because it's probably been wicked into the hole. And there's the last one done. Perfect. Now, yeah, looking at the board, there's no dramas there. Not too much solder on that one for my liking. I think it's wicked in properly. Yeah, that'll do. Okay. Right. So that's our socket in now. Next thing I think we'll pop in is the display. So remember, with the text at the bottom, hopefully that should work nicely. And you may need to adjust the pins to get that to fit in properly. And exactly the same as the IC holder, we're just going to alternate where we put the soldering iron, just to keep the heat down in a specific area. And we'll just again check, make sure that the display itself is flush to the board. Grand. So I'm not going to edit this video, guys, it will be real time, just so you can see how long it takes to do it. And what I will do with the IC is I won't, sorry, not the IC, the display, I won't take the leads off this until I'm content that the display does work, just in case those instructions are wrong, because it does quote a different display model, or a different code at least. Sorry, I hope that was on camera there. So only 3 more components to go in. The 2 capacitors, and those actually fit fairly flush to the board, but probably good to have them just slightly proud of the board. And we'll just let gravity do the work. As you can see, the leads are wiggling around. Okay, and our second one. These are both the same capacitance, so it doesn't matter which way you put them in. Again, we'll have it slightly proud of the board. Let it dangle in there. Okay, so the last switch, sorry, the last component we're going to put in is a switch, and these have got a sort of formed metal lead, and what that does is it basically is a mechanical, you know, it's to add strength, and the way they're formed means that the switch just clips in into place. I'm just going to check that because it doesn't look very clean, to be honest, that the mounting holes here, so I'm just going to gently scrape that a little bit just to expose the track, you know, the plating. Yeah, that'll do. And we'll just pop this in. Excuse me. Tin with iron again. There's the actual switch itself soldered, and then the mechanical sort of element of it. Okay. Yeah, that doesn't look too bad. Feels certainly secure enough. Okay, now I've been toying with what's the best way to do this, whether to put the chip in first or the battery, but I think probably the battery is going to be the best option. In fact, no, we'll put the chip in first. So yeah, this is a 328 microprocessor. It's already pre-programmed, so you might need to form the leads for it to fit in. Went a bit too far on that, I think. The key with these is just to make sure before you really push it home into the socket that you make sure they're all lined up and in a sort of fashion, and obviously you take note that you're putting it into the notch at the end. The notch at the end of the IC goes into the notch at the end of the board and socket. Okay, so that feels good. So just pop that in, and that's seated nicely in the socket, and that again should be flush to the socket and not wonky, and just make sure all the pins are inside before you push it fully down. Okay, so we'll put our battery in now. So positive's on top, so that lead comes down, which means that that's a negative, and we should be able to just slide this in here. And if I press the button, not getting anything just now. Oh yeah, we are. Good, so that means it is working. And I'll probably just rest this, using a piece of the packaging that came with it, I'll probably just rest this on, just so that it keeps it in the correct location for us. So, tin with iron. And we don't want to have too much heat on here for too long, otherwise we run the risk of damaging the battery. And there we can see the battery sitting nice and relatively flat to the board. Okay. And for some reason it doesn't actually want to work now. Well, that's a bit embarrassing. Okay. Right. Yeah, it doesn't want to work. Just double check about that. Now, yeah, definitely positive side. That's going right there. Make sure that's all there. Give the chip a little wiggle. Interesting. Now it could be... what's that doing there? I'm wondering if it's anything to do with the fact that these are through-hole plated. It might be that there's not enough solder has been wicked through to this side, so we'll just try applying a little bit more solder on that, a little bit more heat for it to flow through. Yeah, I think that was the problem. going to give it a little touch on this side. Right, we're working now. Panic over. Yeah, so that's just a, although it's quite embarrassing for me, it's just a, I'm glad that's happened. Basically, this is a dual layer PCB, so because there wasn't enough solder securing the battery contacts to the top side, it basically wasn't making the, you know, the circuit complete. So yeah, that's what that was. Just gonna double check, make sure that's secure. Yep. Happy days. Okay, so that's our, I'll just turn the soldering iron off now. So that's the actual watch itself complete, well the actual electronics of it. And to set this, you just press and hold the button, and it scrolls through the time. And what time are we on just now? We're on 20:52. Excuse me. Well, went too far. We'll call it 21:10 just now. And there you go, it's a fairly nice display, fairly easy to read. Obviously not in direct sunlight, but never mind. So, now that we've established it's working, we'll just trim off the leads. Obviously, if you don't wear glasses like me, make sure you're wearing safety goggles or safety glasses just to stop these getting in your eye and blinding you. And as you can see, they are pretty dangerous. You should really wear gloves when doing stuff like this, because as you can see, two of those little leads have just went straight into my finger. Not very far. Yeah. Not drawn blood. Well, maybe a little bit, but yeah, just be careful. There's the moral of the story. And yeah, next thing to do is to actually put the strap on. So this is done by using the what do you call it, laser cut perspex that came with it. And this can be quite footery to take off, but yeah, a little bit of perseverance. And be careful if you're using a sharp knife like I'm doing, that one, you don't cut yourself, and two, you take care not to damage the nice gloss finish when you're taking it off. Okay, so there we go. And something I failed to do, which I would always advise you to do, regardless of whether it's no clean solder or not, is get our old friend isopropyl alcohol and a paintbrush, and then just scrub over the boards just to get rid of any residual pieces of solder and get rid of the flux, and it'll give you a nice shiny board, as you can see there, nice clean joints, and then you're not going to have to worry about that deteriorating over time. Right, so now that's out the way, we will take our watch strap, and these are quite simple to put together. We take one end of it through like so, and the other end of it through like that, and then the loose end, so I don't know if you caught all that, camera, so we've come up from the bottom In fact, I don't know if that's the way it's designed to go. Let's just have a look at the instructions. Yes, it is. So if you look at the instructions, it's showing the watch strap does go inside, so the PCB will rest on top of the strap, and then down through the brass loop. Okay, and from then on, we need to put our standoffs in, and I'm just checking to see if that goes between the PCB and the perspex, or no, they're on top of this perspex. Sorry, on top of the PCB. Right, okay, so we'll get our little standoffs and nylon screws. Okay, like so. Now the longer ones go through the bottom, I believe, so we'll just pop them through like so, and then locate it into the PCB. And it's probably going to be easy just to screw it from this side, you know, holding the screw and then twisting the actual standoff itself. So there's one in. There's another one nearly in. Yep. And then on this side, we'll just pop that through the bottom. I would actually suggest that this can actually do with longer screws on the bottom, because I'm having to put a little bit of pressure on the board here. There we go. Okay, so that's the bottom part constructed, and then we'll just take off the horrible paper off the bottom parts, top part, sorry. Like so, and we'll just see how this lines up on the board. Yep, quite nicely. I'll just use a little screwdriver here. We don't want to over tighten these, remember, just in case we split the perspex. And then we'll take this little piece that was cut a little bit too close to the bone. And we'll test fit that, like I say, because this looks like it's been cut off slightly. Yeah, that'll do. That'll do the job. Oops. And last screw. We'll just tweak up these ones at the bottom, just give them a little bit of pressure. And that is it. Okay, so I'll take my tom-tom off and we'll put this on and give you a look at it on the wrist. And there we have it. That's our Sainsmart watch. Complete in 30 minutes or so. Maybe slightly less time if you double check your solder connections and all that stuff. But as you can see, it's fairly nicely constructed. I don't think we did a bad job of the soldering. Yeah, this doesn't, this doesn't sit perfectly, but of course, it's just cheap Chinese, isn't it? Perspex, but a nice kit, fairly good components, nice strap, and yeah, a nice introduction to electronics for the kids, or maybe for a school project or something like that. And of course, you could probably hack it to do something else, as it's using the 328, so you could program that to do something and then stick it back in the watch and maybe do a countdown timer or a stopwatch kind of thing. But yeah, that's a Sainsmart LED watch kit, available from Amazon at £9.99 or eBay for £15. Not often you say that eBay is more expensive. So I hope you enjoyed that video, guys. If you did, please give us a thumbs up and please subscribe if you want. I want as many subscribers as I can get, so I can keep doing these videos for you. But take care, and I'll see you again soon for another video. Cheers, bye bye.